Welcome, everyone. I want to start with a question that has haunted scientists for over 7 decades. Imagine looking up at the night sky, seeing billions of stars, knowing many of them have planets, and still asking, are we alone? That's the Fermi Paradox in a nutshell. Today we're going to explore one of the most profound mysteries humanity has ever faced, and maybe, just maybe, come away seeing the night sky a little differently. Here's our roadmap. We'll start with the moment this all began, a casual lunch conversation in 1950. Then we'll look at the staggering numbers that make the paradox so compelling. We'll unpack the famous Drake equation, sit with the unsettling silence of our searches, explore the most fascinating explanations scientists have proposed, and finally ask what this all means for us as a species living on this pale blue dot. Picture this: Los Alamos, New Mexico, 1950. Enrico Fermi, one of the greatest physicists of the 20th century and architect of the first nuclear reactor, is having lunch with colleagues. The conversation drifts to UFOs and interstellar travel, and then Fermi casually asks, "Where is everybody?" It sounds simple, but it stopped the room cold. He wasn't asking about little green men, he was pointing out a genuine contradiction. Given the vast age and size of the universe, intelligent civilizations should have had plenty of time to spread across the galaxy. So why haven't we seen any trace of them? 76 years later, we still don't have an answer. Let's put the scale in perspective, because the numbers are genuinely hard to grasp. Our galaxy alone contains somewhere between 100 and 400 billion stars. That's more stars than grains of sand on all the beaches of Earth. And here's the kicker. We now know that nearly every single star has planets. NASA has confirmed over 5,500 exoplanets so far, and that's just from looking at a tiny patch of sky. The universe itself has been around for 13.6 billion years. If even a tiny fraction of those planets developed intelligent life at any point in that vast span of time, the galaxy should be buzzing. So again, where are they? In 1961, astronomer Frank Drake tried to turn Fermi's big question into something more concrete and systematic. He created what we now call the Drake equation, but it's not a law of physics. Think of it more like a structured way to ask the question. It multiplies 7 variables together to estimate how many civilizations in our galaxy might be sending detectable signals right now. It goes from the rate of star formation all the way to how long a civilization actually broadcasts. The beauty is that it breaks an overwhelming question into smaller, more manageable pieces. The challenge? We only have solid numbers for the first 2 or 3 variables. Everything after that is educated guesswork, and that's where the debate gets really interesting. Think of the Drake equation as a series of filters, each one narrowing the odds. We start with a big number, the stars forming each year. Then we filter. How many have planets? We're already confident about that one. Then, how many of those planets sit in the habitable zone where liquid water can exist? Then, life actually has to begin, and we're not sure how common abiogenesis is. Then intelligence, then technology, and finally the scariest variable: how long does a technological civilization survive? Each step is a gamble. The problem is, we only have good numbers for the first 2 filters. The rest are complete guesswork, and small changes in any one variable swing the final answer from "we're alone" to millions of civilizations. And here's where it gets humbling. For over 6 decades, organizations like SETI have been scanning the skies with some of the most sensitive radio telescopes ever built. We've listened to millions of stars across thousands of frequencies. We've pointed our dishes at nearby exoplanets in the habitable zone. And the result? Silence. Deep, profound cosmic silence. Not a single confirmed signal. Not one. Astronomers call it the Great Silence, and it's genuinely beautiful in a haunting sort of way. It's also the core of the Fermi Paradox, because according to even conservative estimates, we should have heard something by now. The silence is deafening. So now we arrive at the big question. What explains this silence? Over the decades, scientists and philosophers have proposed dozens of possible solutions, and they range from the cautiously optimistic to the deeply troubling. Are we alone because life is just incredibly rare? Or are we being deliberately ignored? Did civilizations rise and fall before we even evolved? Let's explore the two most influential ideas because they represent opposite ends of the spectrum and force us to rethink our place in the cosmos entirely. On one side, the rare Earth hypothesis says complex intelligent life might be incredibly uncommon, maybe even unique. Maybe Earth got absurdly lucky, just the right distance from a stable sun, a large moon stabilizing our tilt, Jupiter sweeping away asteroids, plate tectonics recycling carbon, a magnetic field shielding us from radiation. The odds of all these factors aligning might be astronomically low. On the other side, the zoo hypothesis suggests a very different picture. Aliens are out there and they know about us, but they've collectively agreed to observe from a distance. It's exactly what we do with uncontacted tribes on Earth, like the Sentinelese. We know they're there, we could make contact, but we've decided it's better not to. It's a comforting idea, but also completely untestable, which makes it frustrating from a scientific perspective. Now for the darker possibility, and honestly, this is the one that keeps me up at night. The Great Filter theory suggests there's some barrier that almost no civilization survives. Maybe the filter is behind us. The leap from simple cells to complex life took over 2 billion years on Earth, suggesting it might be extraordinarily rare. That's the optimistic reading. The pessimistic reading? The filter is ahead of us. Climate change, nuclear war, engineered pandemics, misaligned artificial intelligence. Any of these could be the wall that stops technological civilizations before they ever reach the stars. The truly unsettling part is, we don't know which side of the filter we're on, and we won't know until it's too late. I want to pause here with a reflection from Carl Sagan, the great astronomer and science communicator, who thought deeply about this question throughout his life. He said, "The universe is a pretty big place. If it's just us, it seems like an awful waste of space." Whether you find that hopeful or haunting probably says a lot about you. For me, it's both at once. The possibility that we are utterly alone is terrifying. But the possibility that we are not alone, that somewhere out there across the vast cosmic ocean, someone else is looking up at their night sky asking the same question, that's thrilling, and maybe a little terrifying too. So where does this leave us? Still searching. Every single night, telescopes around the world and in space scan the cosmos for answers. The James Webb Space Telescope is analyzing exoplanet atmospheres for biosignatures. SETI is listening with more sensitivity than ever before. The Fermi Paradox isn't just a puzzle to solve. It's an invitation to stay curious, to keep looking up, and maybe most importantly, to take better care of this one planet we know for sure has life. Because until we hear otherwise, this pale blue dot is all we've got. And honestly, that might be reason enough to be a little kinder to each other down here. Thank you.